and then how that was disproved by Einstein, simply because Einstein magnified the lens by like 1,000 scale. So
Yes.
right,
Hmm.
Newton was focused on what was happening on Earth, and it just a bit above that. Then Einstein moved down to like the galaxy.
Yeah.
And then because I was thinking about the fact that there are there are a billion planets in our solar system and a billion solar systems in our
Hmm.
galaxy, and they're probably hundreds of trillions. So that means that if somebody was to zoom 1,000 times away from Einstein's from what Einstein was looking at, there'll probably be another law that would be, so it's almost as if the laws we are discovering are like they're like sets within subsets within subsets within subsets. So there's something larger, and it's just as far as we can see that we're now
Shapes,
using.
you are very wise, bro. You are very wise. That's exactly what's happening, and that's exactly
So
what we
like
have to
the
do.
farther we zoom out.
Yes,
Hmm.
that's exactly what we have to do, and that's why my formula is a more general version of Einstein's E equal mc squared. Does that make sense? Because you know how you mentioned zoom out, right? We're essentially
Yeah.
zooming out. So remember, Newton, the apple fell on his head. He gave us a model, F equal to ma, force and acceleration, right? He gave us a model of
Yeah.
how physical things work, things that we can interact with and touch, apples, even right. And then
Yeah.
Einstein came, and Einstein zoomed out. Einstein said, "Okay, wait a minute. We can go more general. We can zoom out more." And then Einstein gave us a model of the universe, but he hit a wall, and the wall was the black holes. So whenever you interact with really dense parts of the universe, his work relativity doesn't work anymore, right? Because the black hole is so dense that light can't even escape. So his equations fail when you get to really dense parts of the universe, which means that we have to zoom out further to get a bigger picture of his equation. The same way his equation generalized Newton's F equal ma. So it's basically F equal to ma, then it's E equal mc squared. Then there has to be one that is more general than E equal mc squared,
Yeah,
right?
that's
And
actually.
here's my contribution. My contribution was noticing something very, very, very that nobody ever noticed before. Is that we don't need to use the equal sign to model how systems work, because equality itself as a concept limits our understanding of the universe, right? Because we're trying to equate things that are not equal. There's transformation in the universe. Things are transforming into each other. Equality is not a fundamental rule. It's just one of the rules. Does that make sense?
Yeah.
And that's why you have my infinity in the middle. So essentially, check out how genius is shapes, right? E, energy, becomes the triangle, right? Delta, right?
Yeah.
Then the
Yeah.
equal sign becomes infinity. So we are going to generalize equality to infinity, because think about it like this: infinity is a more general form of equality, because infinity models all interactions, not just the equal ones. Does that make sense?
Is that because interactions are continuous?
It's
I mean,
inclusive. It's not as
Yes,
exclusive.
exactly, exactly. And then mc squared, mass times speed of light squared. So remember, speed of light is just a constant in the universe. It's like a measure, it's like a ruler, right? In our universe, speed of light is like a ruler. So imagine a ruler that is
yeah.
12 inches long. That's that's all the speed of light is, right? And then the mass is the only variable that is kind of arbitrary in the universe, because we have different things that have different masses. So essentially,
Yeah.
mass times speed of light should give you the structure of the physical world, mc squared, and that's, we put all that into the circle. So all that becomes the circle. We abstract that because all physical
That's the
things,
Omicron.
exactly, that's the omicron. So essentially, my formula, which is not an equation because it doesn't have the equal sign, my formula is a form. It's a form that represents how things interact, or it represents relationships between things in the universe, right? Everything follows this simple rule: delta infinity omicron. That it's that simple. You said the three ingredients, right? Okay, let's call it ingredients. The three ingredients are delta, infinity, omicron. It's not that we're combining formulas or equations to create this formula. It's that this formula underpins all equations. So it doesn't say that these equations are invalid. Like E equal mc squared is valid. F equal to ma is valid, right? But it's just not general enough to encompass all possible interactions. So yeah, so people get triggered by this, especially when I dismiss equality as a fundamental thing, right? The equal, and I'm not saying that equality is wrong. The goal here is to generalize beyond Einstein's understanding of mass, energy, and light, right? And for us to do that, we have to divorce ourselves from a limiting concept, from a limiting tool, from a limiting language. So equality is useful in Einstein's universe, right? But equality is not necessary when it comes to my universe, or the universe where we have this formula, right? And but remember, I'm not saying that they're wrong. I'm saying that they're not general enough to give us the whole picture. So essentially, this formula is like a lens with really, really high resolution, with the highest resolution. So we can zoom into the universe and see the most fundamental substrate, right? But if you look at the Einsteinian lens, it's a little bit blurry. So it gets us to the point where we understand mass and energy and light, right? If you use the Newtonian lens, you can understand force and mass and acceleration, right? But my lens goes beyond all those formalisms. My lens allows us to understand something that is beyond the material, beyond mass. Because remember, those are just abstractions. Mass is an abstraction. Light is an abstraction. Force is an abstraction. These are all abstractions, and these abstractions are not the most fundamental abstractions. So they work and they're consistent within the framework of Einstein, within the framework of energy. But when we talk about the fundamental rules, it's beyond energy. It's beyond mass. It's beyond speed of light. It has to be more general. Does that make sense, Chips?
Yeah. So, can you just take me through each of those symbols again? The delta now, that's a triangle. You said it stands for what?
So the triangle stands for delta.
No,
So
no,
let me
yes, yes, I know, I know. So that the delta is, but what does it represent
so it
in
represents,
that
okay,
relationship?
correct. So you know what?
I know you mentioned emergence because I'm looking
Yes.
at some of the notes I took. You mentioned emergence, interactions, death.
So look. So go to page three. Are you go to page 3 on the paper? I want to show you something.
Okay.
So there is this principle that I came up with called the general relativistic principle (GRP), and I outlined it on this page on page 3.
Okay. That's is it the core axiom part?
Yes. So do you
Symbol
see the
meaning.
you see the figure one? You see figure one?
So it says quantum domain. Is that the part?
Yes.
Okay.
Yes. So we can put the entirety of quantum mechanics into delta, right? And then we
Okay.
can put the entirety of relativity theory, general relativity theory, into omicron, or the circle, right?
Okay. Yeah.
So, but if you look at page 3, you'll see the relationship there. So
So it
essentially,
says
we start.
mediator. Okay.
Go ahead.
Mediator parameter. That's what the infinity is.
Correct. So the infinity is just a representation of all the possible interactions that we can have that happens in between triangle and circle. Remember,
Okay.
right? A circle is just a triangle with infinite sides. Does that make sense?
A triangle is
So a circle is just an infinitely sided triangle.
okay. Yeah. Yeah. I think I've seen that.
You see what I'm saying? So let's say you start with a s equal to 3 equilateral triangle, right? And then just keep adding one side. You see what happens when you keep adding one side?
If you zoom out, it's like a circle.
You get the platonic solids. You get the rectangle. Then you got the pentagon, hexagon, and
Hexagon.
you
Okay.
go
So
all
yeah,
the way
like that.
to.
Yeah.
So let's say you make let's say the triangle has a billion sides, for example,
Okay.
right? That's still a circle. That's still a circle,
Yeah.
right?
If you zoom out, it's a circle. Yeah.
But it looks really smooth when you zoom out,
Yes.
right? It looks like a
Yes.
circle. But if you zoom in really closer, you'll see the edges still,
Yes.
right? So in theory, we can have a triangle with a trillion sides. In theory, does that make sense?
Yeah.
So this is the engine right here. So the engine is the transformation of a triangle into a circle can be used to model all possible interactions, all possible transformations in the universe. Because that triangle can be S equal to what's Avogadro's number? The number of atoms in the universe is a huge number, right?
Yeah. I don't know.
So we can say S equal to Avogadro's number, which is a really big number. And that's still going to be a triangle, but it's going to look like a circle if you zoom out. So basically, the formalism here is that delta infinity is all the possible in between polygons, S equal to any arbitrary number, right? That's whatever
Mhm.
this big, the smallest to the biggest size. So you can use this to model interactions at a macroscopic level, which is cosmological stuff like planets, galaxies, all that stuff. but you can also use the same language to model subatomic interactions, quantum interactions.